Good evening, my dear students. In today's class, in the chapter kinematics, we are going to discuss the topic motion under gravity, aesthetical ideas. So it's a part of a uniform accelerated motion. So what we had till now, the discussion was like it was uniform horizontal accelerated motion. Now it will be like a uniform vertical accelerated motion, from where that acceleration or retardation will be provided by the gravity. So therefore, specifically, we'll call this as like a motion under the gravity. So let me start the class. So as we will just analyze with a simple theoretical ideas. Let this be a ground. I'm going to release an object. So let's take the two different objects here. So let me put a box. So some box. So some made up of wood, something wooden box it is. Then I will another cardboard box. Which will be lighter. So there's a box one, there's a box two. The one which is made up of cardboard box will be a lighter one. And let's do one thing. Let this be a vacuum. We have created this one. So as I release them, under action of their weight, both of them start falling vertically down. Then at some situation, the weight of this will act m1g. Let m1 be the mass of this box. The second box, let m2. So mass of this be m1, mass of this be m2, which is heavier. So I'll definitely say that m1 greater than m2. The wooden box will be heavier than the cardboard box. Wooden box is heavier than the cardboard box. Both will accelerate, but on both of them, a force is acting. Because of force acting, both will accelerate down. Let me give color. I think some possible. This will be better thing. So now make observation of this. Then what is the acceleration of this? Let it be a1. Acceleration of this be a2. So according to Newton's law, the acceleration a1 should be equal to force acting by its mass. Similarly, acceleration acting on the cardboard box should be force acting on it by its mass. What is the force acting on it? m1g by m. What is the force acting on this? The weight of the second wooden cardboard box, it is equal to m2g. Look at the acceleration of both. Same. So now both of them I released from a height edge. What do I expect? Both are going to strike the ground in the same time with the same speed. Sir, how it is possible? The one which is heavier should reach ground earlier? No. So this is the box. This is the box. Both are going to strike the ground with the same speed. Both will come and strike the ground with the same speed because both are having same acceleration. And both will take same time. So at t equals 0, they were released. What about the instant of time at which it is released? T equal to 0. Now both will arrive simultaneously and they'll strike the ground. Both boxes are released. Okay, there's a very important description. Let me write it here. Both the boxes are released simultaneously at t equals 0 at a height h from ground. Now, what is the finally? Both the boxes strike the ground with the same speed and will take same time to descend. And will take same time to descend. How come, sir? The one which is heavier, this lighter. The one which is heavier should strike the ground. No, if it were this experiment were done in the vacuum, both will, even paper and this, if it is, both will take same time here. The reason for that, because of acceleration. Why do first of all they descend? Because of gravity. So what all this, both the boxes that are having acceleration, that is due to gravitational force. So therefore, these accelerations, what they obtain are due to acceleration due to gravity. And what is the value of G? We'll take the value of G equal to 9.8 meter per second square. Approximately, it will be, for our numericals, we'll use this data. I'll measure this acceleration due to gravity. What is that acceleration? It is in fact equal to 9.8 meter per second square. This will be the acceleration due to gravity that is provided by the gravity on both the boxes, and both are going to have that uniform acceleration. So what is one more important idea? We can put it like both the boxes describe uniform accelerated motion. Both are going to describe same uniform accelerated motion. And how much that acceleration equal to this one. So from where this acceleration will come, I need not apply. The gravity itself will provide this acceleration. So therefore, what shall we write one more thing? The gravitational attractive force acting on the body produces the acceleration for a body. From where that acceleration for a body will be obtained? Due to the gravitational attractive force which is acting on it. So there's a one basic idea from where this one. So you can drop any object, it's going to fall freely. Okay, let's discuss the freely falling body, that one. The first one. Freely falling body. Okay, let me release in. I'm going to release an object. Okay, the object, let it be here. I'm going to release it at certain height and it is going to fall. Okay, let this be the ground. Then it is going to accelerate. It is going to accelerate. So what is the question now? I'm going to release it from a height h. Then what is the time taken by it to descend? Then with what speed it will strike the ground? So all those things we have to analyze here. So what is the acceleration? So somewhere here at intermediate point, it will have acceleration which is equal to g. Because of that, it will acquire a velocity v1. At t equals 0, the body is released. So this is a body or a particle, anything you can put it. And it is going to come and strike the ground with a speed v. And it will take some time of descent. TD will write it. So how to calculate? Shall we apply equations of motion? Because as the acceleration is uniform. So in place of A now, G will come into picture. So therefore the formula will be V equal to U plus AT. Initially it was released from rest. Body is zero plus ZT. Okay, there's a velocity of the body, like with this much of speed, it's going to come and strike. Okay, there's a thing. Or else we'll apply one more formula, V square 0 square equal to 2 plus G plus H. Now, why we are putting all G? I think there's an initial point. This will be final. Look at the displacement. The displacement is downward, no? The displacement is the direction of motion, or with respect to initial velocity. So therefore, they should be positive here. So what is V equal to 2gh? So with this much of speed, it'll come and strike the ground. Now let me use another formula, h equal to 0 td square. Okay, this is d plus g td square. So therefore, this will become. So what is the time of descent? 2h by g. So this is a time of descent. Is given by how much it is? Equal to root of 2h by g. Now what is the type of motion it will describe? We know value of a equal g equal to how much? It is 10 meter per second square. So let's analyze that particular motion, how that motion occurs here. And this will be very, very fundamental one. We'll have the equation in hand. H equal to gt square by 2, v equal to gt. For every interval of time, for t equal to 1, 2, 3, 4, 5 seconds, we will look at the displacement obtained by the body. I think first let me go for the tabular column. T, I think I'll move to the next part here. Let me begin mine. I'm going to release the object at t equal to 0. Okay, I agree this. Then let me define this position as s equal to 0. So here's the object which I'm going to release it. Then in various interval of time, what is the distance covered, displacement, all the things. So I come to the formula v equal to u plus at. It is released from rest 0 plus gt. And we know g equal to 10 meter per second square. So this will become 10. Similarly, what about height descended? H is equal to ut plus of gt square. The body is released from rest. I'll choose particle. The particle is G, the value of G is 10. So on substituting that, we'll get this 5t square. I think these are the two equations which I'll be using for the calculation purpose. So let's go for the tabular column. T is equal to H is height descended. 0, 1, 2, 3, 4, 5, 6. So what is the velocity? Initially, it was released from rest. Then t equal to, so this will be 10, 20, 30, 40, 50, 60, 70. Whatever the height descended, t equal to 0, it will be at h equals 0. Okay, I'll make changes. H equals 0. T equal to 1, 5 meter. T equal to 2, 20 meter. T equal to 3, 45. T equal to 4, 16. 16 5 ja 80. T equal to 5, 25. 25 into 5, 125. T equal to 6, 36 into 5. 5 6 ja 33, 5, 8. 5 6 ja 5 3 ja 15, 15, 180. T equal to 7, 49. 49 into 5. 5 9 ja 45, 4 carry. 5 5 ja 20, 245. Will it come that much? 5 9 ja 45, 4 carry. 5 4 ja 20, 24. Okay, 245 meter. Okay, these are the height. So it will be like this. So t equal to 7 seconds. So now let's indicate that positions. At t equals 0, the particle will be here. At h equal to 0, that one. 5 meters. The same, the particle will come here. Then it will be at high. It will descend 20 meters. 45 meters. 80 meters. 125. I can't go beyond this because the screen will not permit. These are the instants of time: 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Then what is the height? It will descend here, 5 meters. Whatever the positions, this will write 5 meters. Just make some observation. Nothing is there. This position will be 20 meters. This position will be 45 meters. What this height descended? This will be at 80 meters. This will be at 125 meters. So what is the height it will descend? That will take it 5 meters. Next, in another 1 second, it will descend by 50 meters. In the next 1 second, it will descend by 25 meters. In the next second, it will descend by 35 meters. In the next second, it will descend by 45 meters. This is what happens for freely falling object. What is our topic? Motion of a body. Freely falling object. So it's going to describe acceleration. That acceleration is what? G, I'll write it. I think already in uniform accelerated motion, what will happen to the distance covered in equal intervals of time? What is the equal intervals of time? 1 second, in the next 1 second, the next 1 second. So this was the formula. So this was the situation. For equal intervals of time, it's going to have the distance covered will increase, or the displacements are going to increase. In the first 1 second, it will have displacement 5 meters. Next 1 second, having displacement 15. Next 1 second, 25. Next 1 second, that 5 meters, because of uniform accelerated motion. So what is the time it will take to come and strike the ground? So we can say 5 seconds. So how much of height it will descend? 125 meters. So what about the plot graphs, the corresponding graphs? The VT graph, how the VT graph should be a straight line. Then what about the position versus time graph? it should be an accelerated motion. So therefore the curve will be okay, able to understand this? Okay, now it will be, things are very clear here. So what is the time of descent if it is released from a height h? Okay, now let's go for a generalized discussion. If there's a body, I'm going to release it at a height h. After what time it will come and strike the ground? And with what speed it will strike the ground? So we are going to time of descent. So therefore here according to the formula, h is equal to 0 td plus g td square by 2. So therefore what is the time of descent? 2h by g. The same set of formulas, once again I'm writing. And with what speed it will strike it? V is equal to v square minus 0 square equal to 2gh. So the object is going to come and strike the ground with a speed v. And this is the time of descent. So if you release an object at a height h, then after what time it will come and strike the ground? It will strike after some time interval of td. Okay, this is called like a time of descent. Okay, these are some simple, and this will be a graphical explanation. VT graph and HT graph will be of this kind. Okay, let's go for some analysis of this motion. So in freely falling body, it's a thin line. Let me take it. Yeah. No. Let me take the equal displacements. What is these are the equal displacements, delta S. Or I'll increase the size. Delta H will take it. So what about the time intervals to descend this particular difference? So there is some ball. I'll release it from here. Some color. Okay, here this one. So it is going to pass through this particular positions. Then what about the time interval I'm asking? So what can be the time interval? This time interval will be delta T1, delta T2, delta T3. In uniform excited motion, the time taken to have equal displacements will decrease. Delta T3 will be less than delta T2, less than delta T1. Okay. Or we'll go for one more. Okay, this is for this particular situation. Okay, now similarly, I'll bring another. Just now we discussed that. I'm trying to conclude here. Let's take this one. I'll release this object from rest. There's a particle, I'll release it. For equal time intervals, we'll take it now. Just now, previously what we discussed, that only for equal time intervals. Delta H1, delta H2. What about the time interval? They are same. Then the distance covered, the displacement will increase, because the reason for that, because of gravity. Because the gravity will produce that acceleration. So what is the conclusion we can make it? In uniform excited motion, the time taken for equal displacements will decrease with will decrease. Similarly, in equal intervals of time, the displacement of object will increase. Now, what should happen to the average velocity with the help of this? We can compare. So the average velocity should increase as it descends. There's a body or a ball, you can write it. Or you can throw any stone, something, you release it from rest. Ball, release from rest. And what about it? There's a basic motion that it takes place here. So therefore, what are the conclusions we can make it here? Now, regarding velocity is what we can say. The velocity will keep on going to increase here. For a freely falling object, or a freely falling body, for a freely falling body or particle, anything you can write it, or an object, anything. So what is the first thing like? Displacements. So first point here, like and all, the time taken for equal displacements will decrease. The time taken for successive equal displacement. Successive equal displacements will decrease. Next again. For equal intervals of time, the successive displacements will increase. The successive displacements will, for equal intervals of time, the successive displacements will increase. Okay, there's one thing. Anything can we say about average velocity? Average velocity will increase with time or as it descends. So what is the basic idea for this? Average velocity should be equal to v of t dt 0 to t So what is v of t? So v should be equal to gt. Ball released from rest at t equal to 0. There's assumption. So what is the expression for velocity of the ball at any time t given by this one? So substitute this here, gt dt. Integral of this will be t. For any interval of time you can pick up. So this will become g solving this, we'll get average velocity is equal to gt by 2. So look at the average velocity, it is going to increase with the time. So can we go for any plots? Once again, I'm going to bring all the plots here. For a freely falling body, once again, we'll bring all the plots at one place. Oh, to shift this down. Let's compare all the curves. What about the position versus time? So height descended curve will be like this. So what about the velocity? It will be a straight line passing through origin. What about the average velocity? It will also linearly, it will come. Okay, this is for freely falling object here. So again, in the graph also, you can analyze all the things. So this is about the overall picture about for a freely falling object, the average velocity will increase with the time. Then what about the distance covered in nth second here? Any formulas? I think let me dump all the things here only. Distance covered for in nth second. Or displacement in nth second, distance or the distance covered in nth second. So there should be equal to Sn u plus g by 2, 2n minus 1. N is nth second. So what is the height descended, distance covered or height descended? Anything you can put it here. Distance means here vertical distance. Vertical distance covered in nth second is given by this particular formula. If it is released from rest, put u0. If it is projected to certain velocity, take help of this u. Instead of a, g will come into picture. It is about the freely falling. Okay, next we'll go for vertically projected. Vertically projected. Motion of vertically projected. This will be motion of vertically projected body. Yeah, no. We have to describe the, so let me take this as a ground. Here I'm going to project a stone. Let me take a stone or a ball. I'm going to project with a velocity u. This is at t equal to 0. I'll project with a velocity u from the ground. You just take some stone and project and throw it vertically up, or throw a ball. So what can be this ball? Okay, this object, it can be ball or a stone. Then what is the type of motion it's going to describe? As it's going to describe an retarding motion. The stone is going to ascend, and for a while it will come to instantaneous rest here. Then again it's going to descend back. Then what is the velocity? How to calculate the motion of this? So let the velocity be v. The weight mg will act. Then the force is acting opposite to the motion. So this will be retardation. Let's calculate that retardation. So this retardation A is equal to minus mg by m. Why that negative sign? Because that force is acting opposite to direction of motion. So it will undergo retarding motion. So therefore this will become minus g. So what are the equations of motion? It will be now v equal to u plus at, u minus gt. What about height ascended? At any time t, let height ascended h equal to ut minus gt square. So what is the first equation? The velocity of object at any time t. Height ascended by object for time t. Okay, after certain time t, at what height it will be, these are equations. So what is the type of motion it will describe again? So it will be retarding motion. So shall we put this a retarding motion? Or deceleration, and how much deceleration? Equal to g, equal to acceleration due to gravity. So what we have to do, again, we have to study this particular motion in vertically projected body. So what is the maximum height it will ascend? And what is the time of ascent? Okay, this will become the maximum height ascended. Then this will be time of ascent. So maximum height ascended. So we'll apply the equations of motion. Final velocity, here it is 0. And what about the object? Instantaneous rest here. Instantaneous. For a moment, it will come to rest here. Again, it will fall back. So at highest point, it will be at for a fraction of time, it will be at rest. So I'll just call that as instantaneous rest here. So now we'll apply the formula 0 square minus u square equal to 2 minus g into plus h max. These are some very, very important. The sign for in the formula v square minus u square equal to 2ah. The sign for VAH depends on you. If the quantities are directed opposite to initial velocity, should be taken negative. How the G will be directed vertically down. Acceleration due to gravity will be directed vertically down. So why negative sign? Because the acceleration due to gravity is opposite to initial velocity. Final velocity is 0, no doubt. What about the height ascended? It is measured in the direction of displacement, so therefore it is positive. So when you are using these equations of motion, what you should do? You have to use the sign convention. What is the sign convention? Like a final velocity, acceleration, and displacement. If they are measured in the direction of initial velocity, positive. They are measured opposite to that, should be negative. So look at the displacement, how we measure in the direction of initial velocity. So therefore it's positive here. So what is the convention? What convention says? V, A, and H. I'll write it. The convention V, A, and H are taken positive, are given positive, so are taken positive if they are measured along initial velocity u. Or if they're measured or directed, if they're directed or measured along initial velocity u. Measured or directed, anything. Let me just put this slight change, I'll make it. V, A, H are taken negative. If they are measured, directed opposite to initial velocity. Let me put it in proper place. Yeah. Okay, this is a very fundamental thing which we will be taking help of in our discussion. I'll correct it, spelling initial velocity. This is okay. I can just highlight only this much. Leave it here. Okay, fine. This is about the convention. So are you getting reason why G negative? Because it's measured opposite to initial velocity. Why H max positive? Because it measures in the direction of initial velocity. So solving this will end up. So what is the maximum height ascended? Maximum height ascended by the body is equal to H max equal to U square by 2G. Whatever time of ascent, how to calculate? So the time of ascent again will calculate like this: 0 equal to U minus G. So time of ascent is equal to U by G. Let's describe the overall motion, how it takes place. So here I'm going to project in a body with a velocity U. Let's take some velocity 50 meters per second. Acceleration due to gravity we know. So all the equations will be V equal to U minus GT. So what is the U? 50 minus 10t. Then H equal to UT minus of GT square. 50t minus 10t square by 2. So the equation will become 50t minus 5t square. So these are the equations which we'll be using to predict the height of the object at any time t and the velocity of object at any time t. So again, from the tabular column, t, h, and the velocity will be v meter per second. T equals 0. It was I projected at t equals 0, so it was there on the ground. And it was projected with initial velocity 50 meters per second. At t equal to 1 second, it will be at a height of 45 meters. 40 meters. T equal to 2 seconds. 100, 50 into 2 minus 5 into 2 square. 100 minus 20, 80 meters. 30. 3, it will be 20. And at 5, it will come to instantaneous rest. Okay, let's calculate the height. 45 meters, then 35 meters. Then this will be 105. 120. 5 meters. Check the calculation. So it will be 35. So next again, it will descend. It will ascend only 25, 15. And then it'll be 5. Okay, this will be the thing. So finally, it is going to ascend a maximum height of how much? 25 meters. So first 45 meters. One second. It will be at a height of 45 meters. Next at t equal 2 seconds, it should be at a height of 80 meters. 80, 105. I can't erase that one. Okay, let me do one thing. There's a problem. Yeah. Okay. Let's do one thing. Yeah. Okay. These are the 45, 80 meter, 105 meter, 125 meter. This one. The time will be 2 seconds, 3 seconds, 4 seconds, 5 seconds. These are the instants of time. So what is the height it will ascend? Let's see that. First, it will cover how much in the first 1 second. It will cover 45 meter. Next, it will cover 35 meter. 25 meter. 15 meter. 5 meter. You look at this. This is what happens in retarding motion. So what is this motion here? Vertically projected. Vertically, a body projected vertically up. A body is what is its motion? We are describing all these things. No, this is like a retardation. So here, what is this motion here? Retarding motion. Okay, what is the time of ascent? Let's calculate. And what is the maximum height it will ascend? Oh, I think already I discussed here those things. So this will be the maximum height ascended. How to calculate this H max? How to calculate this H max? 0 square minus u square equal to minus g into plus H max. This will be negative. So u square 50 square 2 into 10 into H max. So this will become 125 meter. What is the time of ascent? 0 is equal to u minus gt. Time of ascent is what? U by g. So 50 by 10. 5 seconds. What will happen to the object? Object will not be there. It's going to fall down. This will be instantaneous rest here. Okay, this is about the vertically projected. Let's go for all the graphs, everything. And before that, what will happen to the what will happen to the average velocity, all those things? So that we have to conclude here. So again, I'll take the same. The first motion. Let's take the equal displacements. Or equal time intervals, I'll take it. Then the height ascended will be decreasing. Delta H1, delta H2, delta H3. The time intervals are same. Then instead this, if you consider the equal displacements, what about the time taken for that? In retarding motion, what is the time taken for equal displacement? So should increase or decrease? We'll go back. We'll go back to this. Now we had for vertically ascended For equal intervals, the height as the height descended was increasing for equal intervals of time. For vertically projected, for equal intervals, what be the height ascended? So there are two things are there. For equal time intervals, no, for equal displacement, what is the time taken? Here in this case, here, as it is freely falling, it's going to take the less time, no? No, the time here will be more. I just wanted you to compare things. For equal displacements, delta T1, delta T2, delta T3. So delta T3 will be greater than delta T2, greater than delta T1. It will take more time for retarding motion. The body is projected from here with certain velocity. Let's assume for what we are discussing for retarding motion here. I think this is the primary idea. So again, what are the conclusions we can make it? Delta H1 so for vertically projected body, for a vertically projected body. So what is the first thing like? Height ascended for equal intervals of time will decrease. Height ascended for equal intervals of time decreases. Next again. Time interval for successive equal heights ascended increases. Will increase. Like this will make a what do you expect the average velocity? It should decrease here. Average velocity will decrease with the time. Now, what about the height ascended in nth second? Height ascended in nth second. Height ascended in nth second. That is given by h equal to u minus g by 2, 2n minus 1. Okay, these are the things for vertically projected. A student one has to remember. Okay, let's do one thing. We'll go for the next topic. I'm going to throw a stone. This will be very interesting graphs is what I'm going to bring now. I'm going to project a stone. I think I'll go for a little bit smaller one. Here, ball or stone, anything you can put it here. So this will be. Then what is the type of motion? It's going to ascent. Then it's going to descend, no? At t equals 0 is what I projected. And so let this be 0.1. This, let this be 2. And again, it will return back to the ground 3. So this will be, so here it will be velocity. Here the retardation is G. So from 1 to 2, what is the type of motion? Uniform retardation. 2 to 3, it will be freely falling. And what is the state of the object at 2? It will come to instantaneous rest. The object, actually it will ascend and retrace path. To make things clearly, we're just showing the path somewhere here. So don't think that it will take turn here. No, nothing like that. So what conditions will arise? The object will just ascend. For a moment, it will come to rest here. And from there, again, it's going to descend back. It's going to retrace the path. To explain things, all the things clearly, what happened? We are just showing the other path different here. Hope everyone is able to understand. So what is the time taken for to take turn? No, it will not take turn. Why it will take turn? It will just ascend, descend. We just throw some ball vertically up. So what is the motion of the ball? It will ascend, then will retrace path. No, along the same path is going to descend down. Please try to understand. To explain things, we have just put this curve. Okay, this will be the, you can say it will undergo retardation. So 1 to 2, what is the path? 1, 2. It's what it is, retardation. Then path 2, 3 is acceleration. Accelerated motion, will write it. Retarding motion. Okay, let's write. What is the total? Again, it will descend back. It will take time t. So I want the time of flight of it. I'll apply. So what is the state of this object? Is going to come and strike the ground with the same speed what you have projected. Let's see that. It's going to come and strike the ground with the same speed. So what is this V? We have to calculate here. So it is going to ascend certain height. So will it strike with the same speed? We don't know. Okay, let's cross check on. So for path 1, 2, so the equation will be here. What is the state of here? Instantaneous rest. For a while, for a momentarily, it will be at rest here. Same thing for here also. Instantaneous rest here. So let's apply the first. We'll calculate H max. Applying that one, 0 square U square 2 minus G H max. What is H max equal to? U square by 2G. So what is this? Maximum height ascent rate. Okay, there's a thing. What about the time taken to move from 1 to 2? 0 equal to U minus G T12. What I should call T12? Time of ascent. No, from here, again, it's going to fall the same height, what height it has ascended. What height it has ascended, the same height it is going to fall. The same height is going to descend. So therefore, here it will be b square minus 0 square equal to 2g h max. What is h max equal to? U square by 2g. Let me substitute. 2g h max is u square by 2g. So finally v equal to u. So the body is going to strike the ground with the same speed. So what is the conclusion? Therefore, the body will strike back the ground with the same speed with which it is projected. What is the time of descent? So time of descent should be equal to h max equal to g t23 whole square by 2. What is h max equal to? U square by 2g. What is this? Time of descent it is called as. Time of ascent, this is the time of descent. Look at that, both are equal, no? So what is the total time of flight? The next part, total time of flight. Time of ascent, okay, total time of flight, we write it as time of ascent plus time of descent. So time of ascent plus u by g plus u by g. So it is equal to 2u by g. Or another method, I'll show it with v equal to, there's a very beautifully, I'm bringing this idea. Why negative sign? Look at here. Why negative sign? Because the g is directed opposite to initial velocity u. So therefore this negative sign. Why negative sign for v? Because this v is directed opposite to u. And what is the convention when you're using equations of motion? If a parameter like a final velocity, acceleration, and height, and the displacement, if they're directed in the direction of initial velocity, positive. If they're directed opposite to the initial velocity, they should be taken negative. Hope you are able to notice this. I'll highlight with color. Minus v equal to u minus gt. Why negative sign? There's a condition. And we know the v equal to u. The same formula, both are same, no? This is by time of ascent plus time of descent here. This is directly applying equations of motion. Okay, maximum height, ascent date, time of flight, all we have brought the equations here. Okay, after this, we'll go for the plotting of graph. This is something very important. Let me compare. First, we'll plot the velocity versus time graph. And t is a time. So I'm projecting with a velocity. So first it will undergo retardation. Then again it will undergo acceleration. So it was projected with a velocity u. It will come and strike the ground with a velocity minus u. So what is this? This is u by g. This is 2u by g. This is a velocity versus, and now I'll go for speed versus time graph. It was projected with a speed u. Look at the response of this. Speed cannot be negative, no, here. Speed cannot be negative. So therefore, hope everyone is able to understand this. Speed cannot be negative, whereas the velocity can be positive or negative. Upward, I'm taking positive. Velocity directed upward is positive. Velocity directed upward is taken as positive. And the velocity directed downward is taken as negative. Some convention. Taken as negative. Speed is a magnitude, it cannot be negative. So the curve will be like this. What about the position? The position versus time graph. First, it is going to be retarding motion. Then it'll come to instant rest. Then it like the lead. So the curve will be may not be up to the scale, but it will be let it do. So this is u by g, 2u by g. This is the maximum height ascended. This is what the position or height, you can take anything. So position. This is 0. This is t time in seconds. Now with what speed projected, with the same speed, it is going to come and strike. So therefore, if you take this angle theta 2, so theta 1 must be called theta 2. What about this the highest point? This was like a 0.1. This was 2, no? So what should be the slope of tangent drawn at this particular point? Should be 0, because it will come to instantaneous rest here. So this will be position versus time graph. Hope, okay, these are some very good problems. These are very good conditions. The position versus time graph will be of this kind. So for a body projected vertically up, okay, the curves will be in this way. I just wanted to show them one below other so that you can compare. You can see now this. The slope here must be 0, because at highest point, it will come to instantaneous rest. This is what H max, no? Then it's going to descend. And these two slopes should be same, because with what speed project, with the same speed, is going to come and strike the ground. With the same speed, is going to come and strike the ground. So therefore, these two slopes should be same. Not visible. I'll make it clear. Tan theta 1. So what is tan theta 1? Because change the direction of motion, no? After this. So what is 1 to 2? Retarding motion. 2 to 3 will be excited motion. Okay, this is about the vertically projected body. If a body is projected vertically from certain height, we'll get a condition of like this. Okay, let's take the okay, this is I'm going to project a body from a ground. There's a ball or a stone. It is projected with a speed u. Now, what will be the state of this? There's a ground. Okay, we'll separate. We'll just indicate. Okay, there's a ground. We'll mark it. Now, what is the path? Path is going to ascend. Then it will descend. Again it will ascend. Again it will descend. Like this continuously. If there is no loss of energy due to impact with the ground, the ball is going to oscillate. The ball is going to, in fact, will be oscillate. Okay, let me call this a ball itself. So here it will be. Again projected, again it will retrace path. And this will be a better diagram. Yeah. Now after this, again the path will be. This is for our convenient. Actually, it has to retrace path. It will be very difficult to show. That's why we are bringing the situation like this. I'll keep this arrows. At least you're able to understand. It will be ascending. This will be descending. Again, this will be ascending, descending. With what speed we have projected, with the same speed u, it will strike and it will rebound with the same speed. Some other colors let me use. So what is the condition we have put at t equals 0? We have projected. What is the time here? U by g. After what time it will come here? 2u by g. I'll use different colors. It will be easy for you to notice things. So again, after what time it will be here? 3u by g. Here it will be 4u by g. 5u by g. 6u by g. Like this we can. Again, it will be 7u by g. This will be enough. So like this, the time of ascent, you have to add u by g. So total for the ball to move from the ground to ascend a height u by g. Okay, this is the maximum height. H max. Let's plot the graph of this VT graph, and I'm interested in the speed versus time graph, velocity versus time graph, and also the position versus time graph. I'm going to project it from a ground. Okay, this is the ground. I'll go for smaller one because I have to indicate all the parameters here. Marking, if I do properly, I'll get an exact shape. We'll do one thing. Spacing between the lines should be equal, so that we'll get exact shape of the curve. I'll try my level best to get a good graph. No, we'll do one thing. Let it be. No, first velocity versus time graph. V bar and this is time. So this will become, I projected with a velocity u. First is undergo retardation. So the curve will be this is what the curve. It was projected with a u at highest point minus u. What are this interval of time? U by g, 2u by g, 3u by g, 4u by g, 5u by g, 6u by g. The direction of motion will change, not the gravity here. That the interpretations, how the g will act. Will acceleration due to gravity will change? No. The direction of motion, in fact, varies. No. So therefore, this particular graph indicates here. You should not make this positive here. It's a velocity because after u by g, you see like a t equals 0. The velocity, like a here, the velocity is upward. After u by g, the direction of motion changes. But how the acceleration due to gravity will act vertically down only. So this is a retardation, this is acceleration. The curve should be off like this. Why they should have same slope? Because the direction of motion changes, not the acceleration due to gravity. Okay, let's plot the speed versus time graph. First, it will undergo retardation, then acceleration, then retardation, then acceleration, retardation, then acceleration. This is speed. Speed will just indicate v, that one. So this is speed. Okay, this is what are the time? U by g, 2u by g, 3u by g, 4u by g, 5u by g, 6u by g. Okay, look at the speed versus time graph for a ball projected vertically up. And what is the basic necessary condition? So here a ball is projected vertically up with a speed u from ground at t equals 0. And it bounces up and down with no loss of energy. And let there be no loss of energy due to impact with it. But practically there will be a loss of energy. It cannot rebound to same height. So just after impact, this u will be less than the velocity to strike the ground. So what is the practically how it will be? We're assuming no loss of energy, so therefore that H max will remain same. And let there be no loss of energy due to impact with the ground. So it will just bounce up and down. So the speed versus time graph will be of this nature. Now, what about the position? The position versus time graph. Position again, we have projected it with a speed u. So it will be like this. This is H max. And this is u by g, 2u by g. Okay, like this, the position versus time graph will be there. So what is this last quantity? I should call it as position. So this is what happens for the bouncing ball. If there is no loss of energy, the curves will be of this kind. Okay, similarly, one more graphical thing we'll discuss. For a body, for the ball released from certain height from the ground, and there won't be loss of energy due to impact. The other condition will bring it. So here I'm going to, I think the same diagram, yeah, same diagram will work out. I'll take help of same diagram instead of drawing. I'll slightly modify this. I'll rewrite this data. The rest of everything will be same. Okay, here from the ball will be projected from the ground from certain height. So it will come and strike the ground, u by g. It will ascend here to u by g. Then 3u by g. By the time it comes here, 4u by g. Then it will descend 6u by g. Then this will be 7u by g. Like this so on. So t equal to 0 will be this one. So what is the thing? A ball is released from rest at a height h from the ground at t equals 0, and it bounces, or select it collides elastically with the ground and rebounds to same height, and the motion and such motion repeatedly occurs, and such motion repeatedly occurs. So we'll assume that elastically means no loss of energy here. Elastically means no loss of energy. Let's plot the graphs again. So for first it will undergo here. So it is release from rest. I think a little bit you have to be careful when you are plotting the graph. Some other colors so that it will be. No, it is the ball is released from rest. These are the intervals. I'll come later on. It is released from rest. So what is initial velocity? Velocity meter per second. Okay, there's a time that one. So the graph will be first the velocity directed vertically down. I'll take positive. Then little bit some this is a t equal to 0, u by g, 2u by g, 3u by g, 4u by g, 5u by g. T is in seconds. So it will go and strike the ground with a speed u, then immediately to rebound. This is this part of graph very confusion. I'll release from rest. By the time it strikes, by the time it reaches the ground, it will strike with a speed u. Okay. So here, what is the convention? Positive. This is a negative. Previously, what was the convention? Upward was positive. Downward was negative. You will get this. So here now come for this one. This downward direction, any quantity measured in the downward direction will be taken as positive. It will come and strike the ground with a velocity u. So therefore, this should be positive. Immediately after impact, elastic collision, no loss of energy here. The velocity will be directed vertically up. So this u will be negative. So very next moment, this u will become negative. Then again, what is the motion? First accelerated motion. Then changes direction. Then again, what is the type of motion? Will be retarding motion. So from here now accelerated motion. Collides due to collision, there'll be change in direction of motion and no loss of energy due to elastic collision. Then it's going to undergo retarding motion. The velocity keeps on decreases and comes to instantaneous rest. Then again it will fall back. Again start accelerating. Again come and strike the ground with speed u. Again it will undergo retardation. So this was the graph here. What about the speed versus time graph? Speed will increase. Okay, that one. Then again start decreasing. Then again it will increase. Again it will decrease. Again it will increase. Like that it will decrease. u by g, 2u by g, 3u by g, 4u by g, 5u by g. This is a velocity, sorry, I should write v bar. Okay, able to analyze the thing. So this will be the so the direction of motion. If you say speed should not be negative, no. So therefore, only positive values have to be taken. So the curve will be like this. If you plot VT graph, velocity of time graph, it should be like this. So now look at this one. So here the velocity of the object will increase due to collision changes direction of motion. Then undergo retardation. Then again. So it will freely fall. Where is the freely falling? Freely falling is this one. These are the freely falling. What about the position versus time graph? It was a test, so therefore the position versus time graph will be it is little bit okay. No, I'll put it here. This yeah. There's a position. Okay, this is u by g. Some other color, contrast color, I'll take it. U by g, 2u by g. So on node basis, okay, you'll do one thing. What should be the slope? Should be 0, no? It was released from rest. Look at this, ball is released from rest. Slope should be 0. Then speed will increase. Then the slope should increase. It collide with the ground. Just after impact, the direction of motion changes. So therefore the slope should be negative. Again, the undergo retardation. Again, when it reaches at highest point, it'll come to instantaneous rest. Slope should be 0. Hope you are able to understand this. I just explained for one observation. Release from rest. So slope should be 0. Just just after impact, the direction of motion changes. So the slope, what happened from positive slope should become negative slope. Again, the undergo retardation. The slope should decrease. Comes to instantaneous rest at highest point. Again, it will start freely falling. So the freely falling motion is this one. The returning motion is these things. Okay, like this for a body projected for a body projected from for a freely falling object. So we can write this particular graphs here. This is body released from a height h at t equals 0. Then what about the velocity, speed versus time graph? Okay, the curves will be of this nature. See, we have to analyze here. There's no other way. We have to fight with the basic concept here. Let me. Okay, this is about the theory about the motion, the gravity. Coming class, we'll explore further few more concepts, then we'll enter into the numerical part. Okay, thank you all of you. Okay, kids, like we had a discussion about the motion and the gravity. So we brought certain conventions. If a body is projected from ground, then it's going to ascend. Then afterwards it will descend. Then how to apply that equations of motion. So who was providing that acceleration or retardation? It was the gravity, the weight of the object, that was responsible for the acceleration or retardation of an object here, of a body, that one. So when you project vertically up, the force on a body will act opposite to the motion. So therefore the body will undergo retardation. When the body is falling down, then the weight of the object will act in the direction of motion. So that will provide the acceleration. So that weight of a body due to what? Due to gravitational attractive force. So therefore, what all this acceleration or retardation in the vertical direction in the gravitational field, it is due to the gravitational force only. So therefore, we'll call this acceleration or retardation as acceleration due to gravity. And what is the value of it? It should be equal to 10 meter per second square, approximately exact 9.832 up to 3 decimal places we define. Most of the numericals will assume it to be equal to G equal to 10 meter per second square. So these are the types of like a conventions what we have brought here. And look at all the graphs, time of ascent, time of descent. So many things we have explored here. So try to have a look once, then analyze it, think, and have a firm conclusion. Then when we go for numericals, all these ideas, what all theoretical ideas we have discussed now, we are going to apply them. So you must have first the theoretical clarity. Then numericals will be much easier. So in the coming class, we'll explore the one more topic, then we'll go for the numericals. Okay, thank you all of you. Take care, bye, see you.